Hi everybody, this is me taking up the solutions to the Unit 2 test. Remember, you don't have to watch the whole thing. You can flip back and forth, okay? So, x plus x, first question there. If you have one x and someone gives you another one, that means you now have two x's. X minus x, if you have an x and someone takes away your x, you have absolutely nothing. You could write 0x, but it's better to write 0. X times x, this is exponent laws. Really what you have is x to the power of 1 times x to the power of 1, and when you multiply with the same base, you get x squared. And anytime you take x, a number, and divide it by x, which is itself, if you take something and divide it by itself, you're going to get 1. Polynomial in descending order. So what I do is I look at the degrees of each term. Okay, so the terms, this is term number 1, term number 2, term number 3, term number 4, term number 5. The highest one is right there. So I start there. So I write that term, negative 12x to the 5. The next highest is right there. And so I have 10x to the 4. And then the next highest is right there. So I've got plus 8x to the 3. Next highest is right there, and then the last one is right here. Notice the signs always stay the same. So it's a negative 12, it's got to be a negative 12 out front, negative 2 on the end, it's got to be a negative 2, the rest are positive. How many terms are there? I've counted them, there's 5. The degree of the polynomial is the highest exponent on an x, and that's a 5 right here. A new term that is like any term here will do as long as it has x to the 5. In fact, that would be fine, what I just wrote, but you could also put a number in front. I'll put a 7. I could put any number in the whole world, and it would work. The coefficient of the x3 term is right here. That's the coefficient. So this is the x to the power 3 right here, and so the coefficient is 8. The constant term is, a lot of people put 2, but you have to be careful. You got to take the whole thing. It's negative 2. And then a new term that is unlike something with x to the power 4. As long as you don't write x to the power 4, you're fine. So I'll write x to the power 3. I could write y. I could write x to the power 12. I could just write a number. Pretty much anything as long as it doesn't have x to the power 4 will work. And we'll put a number in front just for fun. Okay, so there's that one done. Next up, exponent laws. So when I have the same base, I add, and so y to the 2 times y to the 3, oops, sorry, one sec, is y to the power of 5. What's going on here? Still getting used to this machine, one sec. Y to the 5. Okay, I'm not sure why it's highlighting like that. And then k to the power 4 divided by k to the power 3, I have the same base, and so I'm going to subtract. So this is going to be k. Uh-oh, what's going on here? Let's see if we can figure this out quickly. Okay, seems to be working. I write k, and a lot of people put k to the power of 1. You don't need to write the 1, because the 1 is assumed. So k is the answer, because 4 minus 3 is 1. Over here, a to the power of 7, all to the power of 3. This is power of a power, and when I have power of a power, you're going to multiply those two things together, not add. So it's going to be a, and what's 7 times 3? It's 21. Down here, I have x to the power of 5, y to the power of 2, all in brackets. Remember, that 3 has to affect that and that. So x to the power of 5 to the power of 3 is going to be x to the power of 15, and y to the power of 2 to the power of 3 is y to the power of 6 because I multiply. 6. I'm not great at writing with this pen, so you're going to tolerate a few little things in this. No. Come on. There we go. There's my 6. And hopefully the other stuff will deselect. Nope. We'll get there. Next one. Again, that 4, the exponent of 4, has to affect x to the power of 3 on the top. So x to the power of 3 to the power of 4 is x to the power of 12. And it's going to be over. And then that y to the power of 2 on the bottom, y to the power of 2 to the power of 4, is y to the power of 8. So you have x to the power of 12 over x or y to the power of 8. Okay? And the last one, it doesn't matter anything in the whole wide world, anything at all to the power of 0 is 1. And so this question was as easy as recognizing, oh, wait a minute, it's all to the power of 0. That means the answer's got to be 1. Okay? All right, next question. 2x plus 5x. Well, if you give me 2 of something and add 5 of something, I now have 7 of something. 3x plus 1, I have to multiply like this. So 3 times x is 3x, and then 3 times 1 is 3. And over here, 10 divided by 2 is 5, and x to the power of 7 divided by x to the power of 3 is x to the power of 4. Just like that. Okay? Keep going here. Now, notice in the question here it says use your exponent laws. Here we go. Exponent laws to simplify. So that means you're not supposed to just put in your calculator, you're supposed to use the exponent laws, meaning that I know that if I have the same base, here I have the same base of 3, and I've got the exponents, I'm dividing, I subtract. So my first move is to go, okay, this is going to be the same as 3 to the power of 5 minus 3, which is 3 to the power of 2, and then it also says to evaluate, and so evaluate means what's the final answer? So it's 9. This one, I have power of a power, 2 to the power of 2, all to the power of 3. That means I'm going to take 2 and the exponents are going to multiply. So I've got 2 times 3, that's 2 to the power of 6, which is the same as 64 when I evaluate. Okay. Next one, if I go in order and do BEDMAS, I have to do the division first. When I do the division, I'm going to wind up subtracting the exponents. So I get 7 to the power of 2 multiplied by 7 to the power of 2. And then when I do this, I get 7 to the power of 4. And I really have to start doing these videos with a calculator in front of me. That is 2401 is your final answer. So I'm simplifying and then I'm evaluating, using and showing that I know the exponent laws at the same time. This one here, so I take this one in steps, and 2 to the power of 5 divided by 2 to the power of 3 is 2 to the power of 2. And then I have 3 to the power of 5 divided by 3, which is really 3 to the power of 1. So that's 3 to the power of 4. And I'm multiplying, so I'm going to put a dot right there. Now once I've got that done, I can't combine these because they're different bases. So all I can do is evaluate. 2 to the power of 2 is 4, and I'm multiplying by 3 to the power of 4, which is 81. And then I just answer that, and the answer is 324. Okay. Moving on, simplify each polynomial. Okay, so this is really about distributing so multiplying and also collecting like terms. So if I look here and collect my like terms, here's a y term, here's another y term, and here's a number. So if I take the y terms and combine them, I get 4y, and I've got a plus 10 on the end, and I can't do any more than that. Next one, here's an x term, here's another x term, I don't have any other ones. Here's a negative 7 as a number, I don't have any other numbers. And then here is a plus y, and I've got this weird thing going on here. When I have two negatives like that, that's going to turn into a positive. So I guess the first thing I'll do, maybe I'll just rewrite the whole thing. And I change this, I have a negative right beside a negative, that's going to change into a positive like that. And so that would be step 1. And then step 2, I'm going to combine them. So 3x minus 5x is negative 2x. I've got 1y plus 3y, so that's going to be plus 4y. And then I have a minus 7 that didn't do anything. So that is my final answer. I can't do any more than that. The next one here, I've got addition between the two brackets, which means that no signs are going to change, and that allows me to just drop the brackets without changing anything at all. So I get that. And now I've got 5x squareds, and here's 10 more, so that's going to be 15. I've got 7x right there, and I'm adding one more. Oh, I shouldn't use underlines, sorry. Plus, so that's 8 x's, and then in terms of numbers, I've got 9 here, I'm taking away 2, so that's 7. Done. The next one here, I do have subtraction right there, and so that's going to wind up changing the sign of that and that. The front one's going to stay the same, so 8x plus 7, and then I'm going to take that 2x, see how it's 2x in the brackets, it's positive 2x in the brackets, I've got to change the sign, it's going to become negative 2x, and that negative 6 on the end is going to change to a plus 6. So now, once I'm done that, there's the next term. Okay, 8 minus 2 is 6x, and then 7 plus 6 is 13. Okay, now we distribute here. When there's a number in front of brackets, so we're multiplying a number, a monomial, times a binomial, both have to be affected. 2 times 3x is 6x. 2 times 15 is 30. Done. This one here, same thing, except I've got to do it twice, and then I'm going to collect my terms. So 3 times x is 3x, 3 times negative 4 is negative 12, 10 times x is 10x, and 10 times 6 is 60. So 3x, I've done the multiplying, now I got to collect my terms. So 3x plus 10x is 13x, and negative 12 plus 60 is going to be positive 48. And that's it, I'm done. Next one, again, I'm going to multiply in front, so I'm going to multiply the 3 by all those things there. I see a subtraction sign in front of these brackets, so the subtraction sign means that all of these are going to switch signs, and I've got a plus 6y in the end that's not going to do anything right away. So 3 times y squared is 3y squared, 3 times y is 3y, 3 times negative 2 is negative 6. I have a y squared inside those brackets, but that negative sign out front is going to change it to negative y squared, or minus y squared. That 2y is positive, it's also going to become negative 2y. The 4 is positive, so it's going to become negative 4. And I've got a plus 6y. And notice the plus 6y is not part of the brackets, so its sign does not change.